Welcome back, everyone. Today we're diving deep into one of the most powerful and most dangerous vulnerabilities in web security: broken access control. This single issue is responsible for millions of dollars in bug bounty payouts, mass data leaks, privilege escalation attacks, and full account takeovers. I'm going to teach you everything from basic theory to real-world examples, hands-on demonstrations, advanced exploitation tricks, and how developers can fix it properly. By the end of this video, you will understand broken access control better than most junior pentesters. Let's begin. Section 1. Ethics Permission. Before we start, always test with permission. That means bug bounty programs, testing labs, or applications you own. Never test random sites. Access control issues directly touch user privacy, so this is serious. Follow scope, follow rules, and disclose responsibly. Section 2. What is broken access control? Broken access control, or BAC, happens when the application allows a user to do something they should not be allowed to do. It may let a normal user view someone else's data, modify someone else's profile, access admin-only functions, or even jump across tenants in multi-tenant applications. There are two major dimensions of access control: authentication, proving who you are; authorization, deciding what you are allowed to do. Broken access control happens when authorization fails. This includes vulnerabilities like IDOR, horizontal privilege escalation, vertical privilege escalation, forced browsing, missing function level authorization, multi-tenant access bypass, role manipulation via tokens. One mistake from a developer, and attackers can read everything, modify everything, or even become admin. Section 3. Types of broken access control. Let's break down every major category so you understand the full spectrum. 1. Horizontal privilege escalation. User A can access user B's resources. Example: get our inverse R10 for return someone else's inverse. 2. Vertical privilege escalation. A normal user performs admin-only actions. Example: normal user accessing or admin delete user. 3. IDOR. Insecure direct object reference. The application accesses data directly using IDs, but does not check ownership. 4. Forced browsing. Hidden pages exist but are not protected. UI hides the admin button, but backend never checks role. You simply call the endpoint manually. 6. JWT. A token-based authorization flaws. If a server doesn't validate tokens properly, users can change roles by modifying claims. This is why broken access control is one of the most impactful issues in real applications. Section 4. How access control should work. To understand what's broken, you need to know how it should work. Access control must always be enforced server-side, never client-side, checked for every request, checked based on user identity, not based on trust in the front end. Using principles like least privilege and deny by default, server gets the correct identity from its own storage. Server checks if the requested resource belongs to that user. Server applies role policies. Server logs suspicious access attempts. Server allows or denies. When any of these steps are missing, BAC appears. Section 5. Demo. Now let me walk you through a simple and powerful demonstration. Imagine I'm logged in as user 1, and I go to user E100 profile. This shows my profile. Now what if I simply change the URL to a user 101 profile? If the application returns another user's data, congratulations, this is horizontal privilege escalation. Why does this happen? Because the backend simply does. Select from users where ID equals. It never checks whether the logged-in user owns that record. This is new hacker's goldmine. Section 6. Enumeration techniques. How do we systematically find these vulnerabilities? 1. Predictable IDs. If IDs are like 1, 2, 3, 1001, 1002, 1003, inverse 1, inverse 2, you can loop them. 2. Path tampering. Modify anything in the path. Profile U10 or edit try, profile 11 or edit. 3. Query parameter tampering. ID equals 101 try other IDs. 4. JSON body ownership. APIs frequently hide sensitive ownership fields inside JSON. Of user underscore ID, R10, amount, R500. Change 10 to another ID. 5. Header tampering. Some apps send user ID in headers like xuser 10, modify it 6, forced browsing. Use tools like FUF, dirsearch, dirbuster to find hidden endpoints. Admin, panel, backup, export, debug. 7. Token manipulation. If token is weakly validated, change role, user admin, change ID, sub, 100-101. These techniques alone can give you dozens of real-world bugs. Section 7. Advanced attack patterns. Now let's go into more powerful exploitation that experienced hunters use. 1. IDER mass enumeration. Once you find a vulnerable endpoint, automate enumeration to harvest all records. Example: inverses, orders, support tickets. 2. Function-level authorization bypass. UI hides admin buttons, but backend accepts the request. 3. Role escalation via JWT. If signature validation is broken or misconfigured, attackers can change role is admin, user_ID. 4. Tenant ID injection. Change tenant ID to access another company's data. This is a major impact in SaaS apps. 5. Race conditions. 2 requests at the same time can bypass authorization flow. 6. Parameter pollution. Send multiple parameters. ID equals 10, ID equals 11. Framework may pick attacker's value. These are the tricks advanced bounty hunters rely on. Section 8. Detection checklist. Here is the exact checklist you can follow. Modify every ID you see. Try accessing objects belonging to other users. Bypass UI and call backend endpoints directly. Change roles and tokens. Tamper with headers, body, path, and cookies. Attempt admin functionality with normal account. Look for exposed admin endpoints. Check every verb: get, post, put, delete. Inspect front-end JS for hidden functionality. Test multi-tenant logic by changing tenant identifiers. If you systematically do this, you'll catch 80% of BAC bugs. Section 9. Remediation. Let's talk about how developers can fix this. Proper security requires authorization checks on every request, validation that resource owner matches current user, role-based or attribute-based access controls, deny by default logic, session-based identity, centralized policy enforcement, logging all denied attempts. Section 10. Hardening monitoring to improve long-term security. Add rate limits to stop mass enumeration. Add monitoring for abnormal access patterns. Log failed authorization attempts. Implement policy engines like OPA for complex rules. Add automated tests for every endpoint. This reduces the chance of reintroducing the bug. If you want to practice these techniques safely, OWASP Juice Shop, Portswigger Web Security Academy, DVWA. These labs contain many BAC challenges. Broken access control is one of the simplest issues to understand but the most impactful to exploit. If you master IDORs, horizontal and vertical escalation, missing authorization checks, and token manipulation, you already stand out as a skilled bug bounty hunter.